Good afternoon, everybody. This is a live severe weather briefing, and we have a lot to talk about, including a threat of supercells today across Pecos Valley into northern Mexico. Then it looks like there's a sleeper day for severe weather across West Texas, with a lead jet streak that's going to eject well ahead of the main trough. And then on Wednesday, it looks like a significant severe weather day across West Texas right now, at least according to the NAM and the other models that are in relative agreement on Wednesday. Confidence is definitely increasing on a substantial severe weather threat across West Texas on Wednesday. Then that system ejects across Dixie Alley, and it looks like a potentially widespread severe weather event across portions of central Dixie Alley, similar locations to where the last severe weather event impacted the Missouri Boot Heel, eastern Arkansas, western Mississippi, possibly as far northeast as the Ohio River Valley. But first I want to focus on today's event, and that is the threat of supercells in Pecos Valley. This is in far southwestern Texas. The Fort Stockton area is likely the potentially the only U.S. town that could see a threat of supercells, as it's pretty sparsely populated down there. But some of these other towns to the east of Fort Stockton also could get some severe weather. And I do think that there's going to be supercells all the way down into northern Mexico. If you're a storm chaser out here, though, do not cross the border. Getting back, I think, could be an issue, I assume. Maybe not. Maybe you might have to quarantine if you do come back. I think that's kind of a deal on crossing any border. Maybe not with Mexico, though. I know that our Canadian storm chasers that are coming down are a little bit deterred by the coronavirus. They are saying that they have to undergo a 2-week quarantine if they come down here to chase and then head back. So that's why our sensors, the Dominator 3, are not going to be in the field for this one. But we are teaming up with some other storm chasers to get ground-based probes to try to do some science out here next week and deploy these probes in the path of tornadoes to get surface pressure falls, wind speeds as well. We're talking to the mad weather people as well, Trey Greenwood, Adrian Mozeris, you may know them. They built a probe that I'm going to try to mount on the roof of the Subaru Forester. Blake Brown has also loaned us his probe as well. But we're trying to scrap together a science mission, even though there's been quite a few disruptions due to the pandemic that's underway. But this is the threat that's today. Southern Pecos, maybe over to the Big Bend region, down into northern Mexico. And we're going to break down this setup first. But I want to briefly summarize the target areas over the coming days. This is the sleeper day on Tuesday afternoon across West Texas, and there is a slight risk that's in effect from the Storm Prediction Center. I haven't produced a target area in Microsoft Paint just yet with this one, but it does look like Lubbock down to Midland, all the way down into northern Mexico, once again is going to have severe weather. And there's going to be a lead jet streak that's going to eject well ahead of the cutoff system, which is now off the southwestern U.S. That's going to be the system that's going to bring significant severe weather on Wednesday across West Texas. And here's that target area that I just produced. You can see the big time trough here. By this time, it's centered over Las Vegas, and a lot of strong flow in the mid and upper levels ejecting out ahead of this system. It's trying to attain a negative tilt here too. This is the trough axis of this trough, and usually when you get a negative tilt like this, you get a lot of diffluence downstream. You get a nicely backed low-level jet as well, and you can certainly get a tornado threat. This reminds me of all those pretty substantial West Texas severe weather events. The Tulia one back April 21st, 2007, for example, March 28, 2007. Those early season, big-time Texas Panhandle events. It looks like the whole entire Panhandle, all the way down to the Mexican border, probably into northern Mexico, are going to see a threat of supercells and tornadoes. And then that threat shifts off to the east, and there's just too many model discrepancies on the evolution after the southern plains on Wednesday. But somewhere across Dixie Alley, maybe all of Dixie Alley, is going to see a pretty substantial severe weather event on Thursday. My plan is to head back out there tomorrow. I had to come back here and make sure things were situated with Gizmo. I'm heading back toward Amarillo for tomorrow night, just to stage for the Tuesday sleeper day, and then I'm chasing every day all the way through this. Now let's look at the surface map. This is the surface map right now down in Pecos. And we only have 2 obs really, but the other obs also provide information. You've got this ob here down to the south of Fort Stockton, where you've got an east-northeasterly wind 70 over 62. This ob right here in Del Rio indicates that there is definitely deeper moisture streaming all the way northwest, and there's likely upper 60s dew points banked up against the mountains here across northern Mexico. We're likely going to see monster supercells ripping off the mountains in northern Mexico during this setup. But it does look like the low-level jet is a little bit marginal across northern Mexico, and I'm going to show you how, some of the maps that support that. So I think that unless there's an isolated low-level jet in the mesoscale right up against the mountains that the models are not depicting, I don't think there's going to be any large tornadoes across northern Mexico. And there is a very narrow area right in this hole of observations where I think that there is a threat for tornadoes, but you can see a lot of stable air, a lot of east-northeasterlies here, north of that instability axis, temperatures in the upper 50s to around 60, even the 40s up here across portions of the Panhandle. But you've got a lot of moisture streaming northwestward along the Rio Grande River there for this setup. Now let's look at the RAP analysis. This will provide us some more information, realizing that there's not a lot of surface obs out there, and so the models definitely have to piece this together just a little bit. But this shows you the convective available potential energy. This is uncapped instability going all the way up through southwestern Texas with a Cape blob down there in northern Mexico. Cape's 4,000 to 5,000 right up against the mountains. Who knows if those are based on accurate obs? I bet they are. I bet you've got 3,000 to 5,000 capes down there across northern Mexico. And then you can certainly see the moisture funneling northwestward along the Rio Grande Valley there. But there are definitely some negatives with this system in terms of the tornado threat, even across the southern Pecos Valley. You've got these east-southeasterly winds, and there is a lot of directional turning. The speed shear, though, out here is relatively minimal, but there is a lot of dry air coming in at the mid-levels. Definitely a prime environment for supercell storms, even all the way up toward the El Paso area. Just to the east of El Paso, there is some juicy air up there, dew points in the 60s, east-southeasterly winds transporting that moisture west-northwestward. And now here's a look at the current effective helicities, and notice how they're maximized right along that west to east boundary that we just saw in the Cape map. You could see that the effective helicities are about 200 to 300 right along that boundary where you get some easterly winds, and you still have a little bit of surface-based instability just in a ribbon right along that. I'm not sure that this is actually surface-based instability. These effective helicities are inflated by those east-northeasterly winds. Those coincide with convective inhibition at low levels. And when we say convective inhibition, it's the opposite of CAPE. If you can imagine a hot air balloon that suddenly becomes colder than its surrounding environment, that hot air balloon is going to sink. The temperature inside the balloon is going to be colder than the air surrounding it, and that creates a stable configuration for that parcel or infinitesimal hot air balloon, and it's going to sink. And so when I say convective inhibition or SIN, that's what it's referring to. It's not convectively unstable, which is when you have positive CAPE. That balloon or the parcel is warmer than its surrounding environment, and then it rises through the air. And the steeper that those lapse rates are with height, the more drastically that those temperatures cool with height, the more likely that that balloon is going to be a lot warmer than the surrounding air and is going to continue to rise. In this case, I think that the model is probably showing a little bit of surface-based instability right along the boundary, but it's probably not having difficulty resolving the edge of that boundary. I wouldn't be surprised if there's a very sharp line between temperatures in the 50s and then temperatures to the south of that in the 70s with those dew points in the 60s. But the problem to the south of that boundary is you have relatively minimal shear in the heart of the warm sector. You've got low-level shear of about 50 to 100 meters squared per second squared, and that isn't quite sufficient for a robust tornado threat. But there are some orographic effects that happen out here in the Pecos Valley in northern Mexico where you get a mesoscale low-level jet that I believe is stronger than many of the models can resolve, and that leads to a little bit of a localized hotspot here across southern Pecos Valley where you can locally realize the wind shear necessary for tornadoes. But then I step forward with time, and you can see that the wind shear even gets less favorable for tornadoes, and this is at 22Z at about 5 o'clock this afternoon. You've got like 25 to 50, 0 to 1 kilometer shear, and you kind of have these clusters of storms that are going to be rolling off the higher terrain of northern Mexico and the Pecos Valley. Maybe a couple storms further north in the vicinity of that boundary, but the models are trending a little bit less with that threat. Nevertheless, though, I'm going to plot some hodographs for you. This is the HRRR forecast 0 to 3 kilometer energy helicity index, and this is a composite index between instability and wind shear. And this is in the 0 to 3 kilometer layer, so it takes into effect 0 to 3 kilometer shear and then surface-based cape through the whole entire layer. And I picked a sounding right near the boundary, pretty close to the Pecos area along the I-20 corridor, where you can see a little bit of an enhancement in the low-level shear. And now I'm going to show you this hodograph from that location. This is the forecast hodograph that I picked up from the HRRR. You can see those easterly winds at the low levels. This is the surface. That's an east-southeasterly wind at about 15 knots. And look at this directional shear with height. This is looking down at the atmosphere, and it's basically a way to visualize the wind shear in the atmosphere. But you've got a surfaced wind and of east-southeasterly at about 15 knots. Just above that, a kilometer up, you've got a near due south wind over 20 knots. It's a pretty modest low-level jet, but with all this directional shear, you're getting quite a bit of a curved hodograph still. Then 2 kilometers up, you've got a southwesterly wind, and then 3 and 4 kilometers up, you've got a southwesterly wind of 35 knots. So basically, you're plotting these vectors. These are wind vectors that have a direction and a magnitude. You plot the dot there, and then the hodograph just simply connects those dots of the winds at different levels of the atmosphere. And you can see as they're spiraling up. And if you have a more curved hodograph like this one, it's more favorable for supercells and also tornadoes. You can also plot the storm motion vector, which is southwest to northeast at about 20 knots there. And that creates a critical angle that is pretty close to 90 degrees. Really, your 0 to 1 kilometer shear vector is like this, somewhere between this and this. So you're looking at a critical angle that's more than sufficient to get quite a bit of storm relative helicity within this environment. That's the area enclosed by the hodograph curve and the storm motion vector. That's big time helicity right there. But I'm not sure that this is going to be realized. This is pretty close to that stable air. There's only a narrow ribbon in the Pecos Valley where I think that there could be a tornado threat. But this hodograph right here is definitely a hook-shaped hodograph. We're going to see a lot of these throughout the week moving forward. West Texas on Wednesday, Tuesday in West Texas as well, the sleeper day, maybe not as favorable of a hodograph as Wednesday. And then Thursday, those hodographs attain more of a Dixie Alley configuration, where most of that hodograph is located here in the northeastern quadrant. But we break down hodographs big time in the Facebook supporter group quite a bit. We plot these hodographs as well. We try to understand and visualize the wind shear in the atmosphere using these hodographs and really have a deep understanding for the ingredients that come together for severe weather. So here is the sounding that was used to produce that hodograph, and you can see those east-southeasterly winds at the low levels at the surface and a lot of directional shear. So you have this layer of east-southeasterly winds, as often happens across the high plains, whether you're dealing in northern Mexico this time of year or in eastern Wyoming later on in the summer. You get a lot of directional shear, a fairly relatively deep layer of easterlies, and then flipping around to do southwesterlies just above in the atmosphere. And that a turning with height creates highly curved hodographs. Here you can see a little bit of that capping inversion, probably related to that front moving west or west to east, but really there's going to be a difficulty breaking that cap right near that stable air. The storms are going to have a tendency to want to cross into that stable air and become elevated further south into northern Mexico, closer to the Rio Grande River. Those storms will definitely be surface-based in an unimpeded warm sector, but the shear is not as favorable as it is a little bit closer to that west to east boundary. So that's what's happening today. Now I want to go back over to the forecast models and break down some of the setups moving ahead, and also look at the potential for a snowstorm across eastern Colorado next week as well. And that depends on the exact track of that Colorado low, where it develops downstream of this big storm system, and then where it moves with time. But let's break down and see exactly what these models are showing. This is the NAM model forecast for 0Z Wednesday evening. This shows the trough with the negative tilt that we were talking about. Big time severe weather across West Texas with this. You've got 50 to 60 knots at 500, drilling down in the atmosphere at 700 millibars. You've got 40 to 50 knots. That's a very strongly sheared atmosphere across West Texas. where 850 millibars is actually closer to the surface. So you're looking at closer to surface winds with the 850 millibars there. And then let's look at instability. And this is on the NAM, but you can see quite a bit of instability showing up here in the central Texas Panhandle, even into western Oklahoma. But I suspect that the dry line will set up somewhere across West Texas, down into southeastern New Mexico, into southwestern Texas, with severe weather moving northeast from there. So now let's look at the, let's look at the GFS. We might as well for Wednesday. And you can already see there's big differences beyond 84 hours in the evolution of this. Definitely it has a negative tilt, almost like a bean-shaped 500 millibar low. A lot of flow coming out on the southeastern quadrant of this upper level system and overspreading West Texas there with a lot of wind shear. So let's look at the next day. This is on Thursday. And look at how this trough ejects. Look at all this flow ejecting out here. This is going to mean that the severe weather is going to be over West Texas on Wednesday, and then it's going to jump way over to the east. Portions of southeastern Missouri, Illinois, eastern Arkansas, western Mississippi, Tennessee, Kentucky, likely to have a big-time severe weather event and much more widespread than the preceding days. And here is that Colorado low I was telling you about. The GFS has it at 987 millibars by Thursday evening, has left Colorado. Still big-time upslope, blizzard conditions happening here on the backside of that system. Starting to depart, blizzard conditions across western Nebraska, northeastern Colorado, also central South Dakota. And that low pressure lifts off to the east-northeast. And look at how quickly it's off the New England coast by Friday evening. So this system goes from being a cutoff over the southwest to quickly ejecting and then being off the Atlantic seaboard very, very quickly. Let's see what kind of accumulations the GFS is showing in the mountains. And the GFS shows a little bit of a drier storm across northeastern Colorado. It is going to be windy, probably another windstorm type of an event. You may remember the last year's bomb cyclone. And the GFS has a little bit north of a track. So it has the heaviest snow falling from Cheyenne up across southeastern Wyoming, Elk Mountain area, easily 1 to 2 feet of snow up there. Definitely has the mountains of Colorado getting hammered. Skiers, that doesn't matter as much because all the ski resorts are closed. But let's see now what the European track has for this same snow. And the European also has southeastern Wyoming, Cheyenne into the Nebraska Panhandle, just getting pummeled by a big-time snowstorm, probably a blizzard, southeastern Wyoming into the Nebraska Panhandle. And the European has several inches of snow falling in Denver as well, and the Colorado foothills. But these latest models are showing a little bit further north of a track of that surface low. So if you live in Cheyenne, Lusk, Chugwater area, you're going to get hammered by this snow event, most certainly. But these Colorado lows can be fickle. They can come out at different angles, different latitudes, positions. If this were to come out just a little bit further south, and this would be Denver getting the 15 to 20 inches of snow instead of Cheyenne. So we're going to have to watch this closely and see what this exact track is. If it's just 3 counties to the south, down in this direction, then you're talking about Denver getting hammered by that big snow. So that's really what we got right now going on in the weather. I'm going to be in chase mode again. I'll be sending those live streams through my Facebook supporter platform again, and I'll just stream to everybody since we're all in the same boat here with this virus. A lot of people at home, no sports to watch, but at least you can watch storm chasing, watch these weather reports. Stay tuned to the Radar Omega app as well. I'll be posting a lot of radar information from their new high-resolution products. Good friend of mine, Don Murray, is the one that developed that. He's working with a team of developers now to roll out Radar Omega. We're going to keep using that and tracking these storms with those new high-resolution products. So thank you, everybody, for joining me today. I'm doing my part to try to minimize the coronavirus. I got rid of the mustache. I can always grow it back. But I was just reading the things from the CDC that if you have too much facial hair, that it could be a negative for the spreading of the coronavirus. But I'm going to grow this thing back again, especially in the cold season. I'm going to continue these updates. Stay tuned to these storm chasing updates and my weather reports. And have a good rest of your Sunday. And be sure to watch lots of TV. Be well, everybody. Never stop chasing.